Hello and welcome back to the Precalculus1 for systems of nonlinear equations in two variables, but that was too long to write, so we'll just say systems of nonlinear equations, and it's going to be two variables. So the goal is to learn how to solve the nonlinear systems. We have seen systems in two equations, two variables, three equations and three variables. And now we're going to learn about systems, the nonlinear systems, and those will have x squared and you know stuff like that. Before we jump into it, I will mention that you can have different types of solutions here. So why are you red? 7.1 will introduce something like this, where you have a point xy to be a solution, or lines are parallel, and if the lines are parallel, that's a no solution, and you can have one line graph on the top of the other line, so that's infinitely many solutions. This is line 1, line 2, line 1, line 2, whatever, it doesn't matter. Now you can have the same situation happen, well, there are more infinities of the solution 7, 2. You are intersecting planes. So you can have x, y, z, one solution. You can have no solution with being parallel. So think of the floor and the ceiling. Floor and the ceiling will never intersect, therefore they're parallel planes, and then they don't have a solution. But then the wall and the ceiling, they do intersect at that line, right, which is the 90-degree bend between the two, and that line goes infinitely, you know, left and right, therefore infinitely many solutions for that. So we can also have infinitely many solutions if we want to. Now what's happening in 7.4? In 7.4, you can intersect y equal x squared and let's say y equal, let's go with x plus 3. Now if you are to graph that, here's your parabola, 1, 2, 3, 45 degrees. You'll be sick of these types of problems in Calc 2. You need to know how to solve this. I mean, this is going to be Chapter 6 and then Calc 3, obviously. If you're going there, a lot of this stuff. Alright, so how many solutions do I have? Well, here's one. And here's another one. So in this case, I have two solutions. Expect two solutions. Now, the way to solve is always going to be either substitution or elimination, right? And we can just say set y equals to y. So what do we get? We actually get x squared is equal to x plus 3. Right? Because if y is equal to y in the substitution method, then x squared is equal to x plus 3. So this is now x squared minus x minus 3 equal to 0. And luckily this factors into x minus... Oh no, it doesn't factor. Oh. Can I change it into whatever? Use the quadratic formula. 1 plus minus 1 squared minus plus 12 divided by 2. That is 1 plus minus square root of 13 over 2. There we go. So when you use the quadratic formula, you get these values. And if you want to know what you get, you can use the abacus to calculate square root of 13. So 1x is going to be 1 plus square root of 13 over 2. And then keep one decimal place. It's, you know, I mean, can you really graph an x, you know, going to 7 decimal precision, right? One is enough for these problems. So 1 plus square root of 13 divided by 2, and we get 2.3. Can do the squiggly sign, and we, you know, this should be about 2.3 for that one. And then the other one is 1 minus root 13 over 2. So 1 minus square root of 13, and then divide by 2. We get about negative 1.3. Oh, look at that, negative 1.3, right? So it makes sense, right? If you just sketch the graph close to what this thing looks like, then you would get these x values. Now you are supposed to calculate y values as well. And that's very easy to calculate because you have that y is equal to x squared. So you can just, you know, for y square 2.3. And over here y is negative 1.3 squared. So you just run those in your calculator, right? So that's 5.29, so 5.3. And 1.3 squared is just like 13 squared, which is 169. So this is 1.69, so about 1.7. So we have one to be 2.3, 5.3, and the other one to be negative 1.3, 1.7. We can also see that this one is, you know, where the 5.3 was about. So this point here is supposed to be 2.3, 5.3 about, and the other point in here is supposed to be negative 1.3, comma 1.7. Now you see that the y value is positive because obviously it's above x-axis. For both of the points, y value is positive, and then for these 2 points you have a negative x value for the left point and the positive x value for the right point. So visually, right, it makes sense to have these numbers. We know this is okay. Now obviously you can try those in, you know, in here and check. So 3 minus 1.3 is 1.7, and 2 plus 3 plus 3 is 5.3. So it's good. And believe it or not, that's the lecture. Now, running you know, infinity of these possibilities to solve these equations in terms of what if I intersect a circle with a parabola, or circle with a line, or what if, right, what if this, what if that? Well, all you need to do is to go and compute all of the values, right? So let's take a look at, you know, more of these examples. Now I'm going to summon the textbook, open it up with 7.4, which is right here. I opened it actually randomly on 7.5, which is nice. However, the other day I did open my differential equation randomly on the page I exactly needed. So that was fun. Okay, so let's see, what do I have? Problem number 6. right? When you look at these problems, right, what the functions or lines look like, you should know what they are because we studied all of these. So x squared plus 4x plus 5 and y equals x squared plus 2x minus 1. So you're looking at these two and you say, oh, these are the two parabolas that open upward. So what can I have? I can have a fat parabola and then a skinny parabola like this, and they have no solution. Or I can have a skinny parabola and then the fat parabola like that, and then they create two solutions. Right? Those are my options. And then there might be a way for them to actually be a fat parabola and then a skinny parabola, and then they intersect at one place. So these are the configurations, right? You just think a little bit about it. And let's see, you know, how, so you're expecting no solution, one solution, two solution. One thing you can't have is three or more. You can't have those solutions because in order to create more solutions, they need to bend back, right? This one will forever go this way, and then this will be forever going away from it. So they don't bend in any way to create extra solutions once you are done with what you have. All right, cool. So we know what to do. Set y equals to y, which is the basic substitution method, and you get your x squared plus 4x plus 5 equal to x squared plus 2x minus 1. Now, when you subtract everything to the same side, you get 2x plus 6 equal to 0, right? X squared minus x squared is 0, 4x minus 2x is 2x, 5 minus minus 1 is 5 plus 1, which is 6. Cool. Well, x is 3. That's obvious. And then use any of the equations to calculate y. So y is going to be 3 squared plus 2 times 3 minus 1. I'm using the second equation because it has smaller numbers and I'm lazy, right? So that's 9 plus 6 minus 1, which is 14. So the answer is 314. Nope. No one caught the mistake. That's a negative 3. You guys are not paying attention. So that's 9 minus 6 minus 1. And that's 9 minus 6 is 3 minus 1 is 2. Did I? I messed. Yeah, good. All right. So what do we have? We have two. The chat is slow down. You're flying. Yeah, the beauty of the YouTube is that once you rewatch the video, you can put it on any speed you want. What is that thing? I actually never used that feature. Okay, cool. Just wanted to find. All right. Oh, more. Okay. Sounds good. So I have two parabolas, and we have a couple of configurations that we could get with their solutions, right? The method of solving is we set left equal to right. I mean, equal equations equal to each other, which is done here, and then we put all the like terms together. X squares will cancel. 4x minus 2x is 2x. 5 plus 1 is 6. And when you subtract 6 divided by 2, you get your x is negative 3. Then you plug that negative 3 into any of the equations to come up with a y value, which was 2. And there's your solution. Problem solved. Okay, what else can we solve? I approve of that speed. Yeah, once you click on YouTube, the half speed or a quarter speed, and then I can really slow. All right. If they make us wear masks coming back in September, I am so buying that Bane mask, and I'm going to do the accent too. It's gonna be epic. Alright, so next problem is problem 17. Alright. Here are the two equations. And what are they? Well, the top one is obviously a linear equation, y equal mx plus b. And the bottom one is, what's the bottom one? This was your intermediate algebra. And you will do this again in Precalc 2. The first thing you do in Precalc 2 would be chapter 9, which is this stuff. Anyone recognize the equation on the bottom? So, yeah, it was there in chapter 1 as a review section. We skipped it, but then I didn't skip it. I talked about it still. Uh-oh. By now, at least like 5 of you should have just written that it's equation for a circle. Centered at, yeah, that's it. 1, -2. Perfect. All right. So, one equation is the linear line, other equation is a circle. So, circle can be intersected with the linear line, creating two solutions. The line could just kiss the circle. There we go. One solution. Or they could just miss each other completely and have no solution. So these are all possibilities that we have. Now, if you want to actually sketch this and see, then just sketch it and see, right? We have our center at 1, -2. By the way, we reviewed this in 1.9 2.5 months ago. And we have our radius to be square root of 10, which is about 3.123, whatever square root of 10 is. What's square root of 10? There's a 6 over here. I was off by 6 cents. So if you want to graph this and see, there we go. There, much better. And then the 0. 0 is in the middle. So what do I have? I have the center at 1, -2, 1, -2, and then I need about 3.2 units each side to make a circle. Again, you don't have to sketch this. Those who do sketch it will immediately know how many solutions they're expecting. So this is 3.2, 3.2, 3.2, and 3.2. And now we just, do the circle the best we can. Say this is good. This is 1, -2. on the center. The other equation, x plus y equal 1, is actually y equal negative x plus 1, which is 1 and then negative 1 slope. So if I did this sketch precisely, I'm going to make a guess for my answers. 0, 1. I see two answers because the lines intersect in the two places. So 0, 1, and what is this one? 1, 2, 3, 4, 4, negative 4. Now that's not good because I already see 4, negative 4 doesn't work because 4 plus negative 4 is 0. So 1, 2, 3, 4. 1, 2, 3. Oh, negative 3. Negative 3. Yep, thank you. Yep. Negative 3. So now, if I try both of these, they work in a first equation. And if they work on a second equation, I am done just by looking at the graph. Now, that's not why we're all here today in such a great numbers, right? You want to see this solved by algebra. But this shows you that, right, if you have the OCD, square paper, instruments, steady hand, and will to do it, you can solve it using graphic procedure and not mess with calculations, right? In this case, OCD is highly beneficial. Anyway, let's see the way to solve the equations. I have x plus y is equal to 1, and x minus 1 squared plus y plus 2 squared is equal to 10. From the top equation, solve it for x or a y, right? Whatever. You can say y equals 1 minus x. And plug in. That's your substitution method. You are substituting for y, right? You're substituting 1 minus x for y. So what do I have? I have x minus 1 squared plus, instead of y, I have 1 minus x and I have plus 2 equals to 10. Note that I don't have, let me just put this orange. So note that I don't have any of these, weird things happening here. And now, square it out. X squared minus 2x plus 1 plus, this is going to be 3 minus x, right? Squared, is it? 3 minus x? Yeah, 1 plus 1 and minus x. Good. So now that's 9 minus 6x plus x squared when you FOIL it. Don't forget the middle term. Put all of this on the pile, meaning combine like terms. It's gonna be 2x squared minus 8x. And then this is plus 10, but then you have minus 10 from the other side. So that dies. And you are left with a good solution. There we go. Those points I gave are correct. Nice. To solve the quadratic equation, we go to our basic algebra, where we use the GCF, right, greatest common factor. So we factor out 2x, then the zero product rule to set each one to 0. X is equal to 0, and x is equal to 4. I have those two. X equals 0, and x equals to 4. Woohoo! So now you can use the substitution equation of y is equal to 1 minus x to get the y's. So 1 minus 0 is 1, and 1 minus 4 is negative 3, giving us 0, 1, and 4, negative 3, which is what we had from before. Can a horizontal line going through a sine wave be calculated to have less solutions than a matching sine wave? Okay, so that's a pre-calculus question. And the number of solutions in a trigonometric function is infinite unless you provide the interval, because the wave is infinite. I'm not sure why you're asking that in a pre-cal course, but there you go, right? And horizontal line, and as you can see, this wave will go forever, right? And it will create infinitely many answers. I don't know why this question is there, but it's okay. I mean, I'll answer it. That's a pre-calc question. You will deal with it in chapter 5 when you take your pre-calculus course. I think 5.3 or whatever the chapter is. I can look it up. So that answers that. But I thought that the y x squared was negative x squared, canceling out x squared. Why? It's x squared plus x squared. That creates 2x squared. I'm not sure why they canceled in the previous problem, because in the previous problem was a different configuration. They were on different sides of the equal sign. So when you subtract x squared to put them on the same side, then they cancel to 0. But that was previous problem. In this problem, they are on the same side of the equal sign, here and here. This is where the equal sign is. So x plus x is x 2x. Ah, yes. Negative x times negative x is positive x squared. Yep. All right, cool. All right, next example. We have nothing else to learn. If you know shapes and graphing and so on, you will know how many solutions to expect. If you don't know that, then just, plow through calculations, and whatever it spits out is what you get, right? Without confirmation, but it's possible. Let's take problem 12. X squared plus y is equal to 4, and 2x plus y is equal to 1. I'm never ready to type. All right, so what is this next problem? Well, if you look at this one turns into y equals negative x squared plus 4. And the one on the bottom is y equals negative 2x plus 1. So these are my equations. This is a parabola opening downwards like that, and this is a linear line that falls to the right because it has a negative slope. So what can you expect from this configuration? You can expect no solution, one solution, or two solution again, right? Remember, If they miss each other, like this, no solution. If they kiss, which is at one point right there, then it's one solution. And if they cross like this, it's two solutions. Now, the way to solve this, this in chat was supposed to be 10th to 12. It's just that I don't know where that extra one came from. All right. To solve this, the fastest way would be to subtract equations. Subtracting equations is equivalent to adding equations where you multiply the bottom one by -1. That's, 2 steps. Just subtract them. So y minus y will cancel. What are you left with? X squared minus 2x equals to 3. That's what you're left with. Move 3 to the other side. And now we have basic quadratic equation that we should be able to solve from elementary algebra. So what do we have? We have x minus 3, x plus 1. So x is 3 and x is -1. Use the y equal -x plus 4. The -x plus 4? No, that's x squared. You can use the other equation as well to get your y's. Y equals -3 squared plus 4. That's -9. Plus 4, it's -5. Y. And this one is y equals -1 squared plus 4. That's -1 plus 4, which is 3. So we have 3 -5 and -1 3. Ta-da! Let's do another one because we want to see something that has a little bit more work. Trying to find the intersection of maybe circle and ellipse. Again, all of these equations and things you will see more in Precalc 2. We're just getting our feet wet over here a little bit. Looking for a circle and ellipse intersection. That's a circle and circle. Aha! Problem 29 has 3x squared plus 4y squared equal to 16. Ooh, this is even better. Actually, this is ellipse and hyperbola. Nice. You don't need to know these now. You will learn them in chapter 9. Your first chapter of Precalc 2. But right now you are learning just mechanics of those calculations, and you will learn the details of these formulas later. Now, when you have a plus sign, that's going to be an ellipse. Ellipse could be like this, let's say. And then the one with the minus is the hyperbola, which could look like that. So clearly, you can have 4 solutions. You can have 3 solutions. You can have 2 solutions. You can have, by the way, this is the iosauron, right? Good. And this one over here is a no solution. Oh, 1 solution. And no solution. So 4 solutions, 3 solutions, 2 solutions, 1 solution, no solution. Again, you don't know these shapes, you don't know how to graph these shapes, but once you take the chapter 9 in Precalc 2, you will be able to connect what the new knowledge you learn about graphing and these shapes. You will be able to connect those to the mechanical calculations that you are now getting. No one is asking you to learn about hyperbolas, ellipses. You should know about circles and lines by now, but right, and parabolas. But you need to know that all of these equations that you are writing are just equations of some mathematical concept that you will learn later. The intersection of 3 by 3 equations are intersection of 3 equations of the plane. So you can literally think of the 2 walls and a ceiling creating that corner point in the corner of your room. Look at the ceiling, look at the 2 walls below that ceiling that meet, and all 3 of them meet in that corner. Each one of those equations that you are, each one of those 3 walls that you are looking, so 2 walls and a ceiling, right? Each one of those is represented by one of the equations, and then when you do the solution you get is this point in space that you get in that corner, how many feet from 0, 0, and so on. And it's just, application for this all over the place, but we don't really learn it that way. Now we are mainly learning mechanics of how to solve these things. Anyway, what do I do to solve the system? You do the same thing you would do to solve the other systems. You eliminate one of the variables by multiplying, in this case, top by 3 and bottom by 4, because they will create a 12 on the y squared, and that will kill y squared. So when I multiply by 3, I get 9x squared plus 12y squared equals to 48. And when I multiply bottom one by 4, I get 8x squared minus 12y squared equals to 20. When I add these 2 equations, I get 17x squared equals to 68. And if all of this, so like 3 times 3 is 9, and then 12, and then 48, and then 8, and then negative 12, and then 20. Just want to make sure I copy this right, because this doesn't look good. 3x squared plus 4y squared equals 16. 2x squared minus 3y squared equals to 5. Yep, I got it. All right. So now, divide both sides by 17, and you get x squared is equal to 68 divided by 17. Is 4. And here is the $1 million move. Square root both sides, you get a plus and minus on this one. So x is equal to plus minus 2. That splits into x1 equals to 2, x2 equals to negative 2. when you square root both sides of the equation, you will have to do the plus minus on both sides. So now, when x1 is equal to 2, pick one of the equations. You have 3 times 2 squared plus 4y squared equals to 16. Solve that. That's 12 plus 4y squared equals to 16. That's 4y squared equals to 4, right? 16 minus 12 to combine like terms. Y squared equals to 1. What do I do when I square root both sides? Plus minus. So it spits out y equals plus minus 1. So my x1, which is 2, spits out 2 y's. That means 2, 1, 2, negative 1. This will be very important for Calculus 1 calculations when you do the optimization problems. So, yeah. Now, that only takes care of that one. I also have x2 is equal to negative 2. 3 negative 2 squared plus 4y squared equals to 16. Okay, this works out to be the same. Yeah, y equals plus minus 1. So that gives us negative 2, 1 and negative 2, negative 1. We have 4 solutions in this problem. It is that first one where the ellipse was intersected by hyperbola. It could be this way. I mean, I don't want to go and explain how these things work geometrically, but this is the one that intersected. Now, those of you who want to see this and confirm these answers, you can go on Desmos and graph these two equations. It will intersect. You will see exactly where they intersect. So on. So the question asks to do one with the 3 solutions or more. Here, that was the one with 4 solutions. Where are you getting 3x squared plus 4y equals to 7? Where are you getting 3x squared plus 4? 3x squared here. It's a statement of the problem. These equations here are where we multiply by 3 and 4 to get ready to kill the y's. This is what the problem is right here. Given in a book, these two. And then you fix them so they can kill the y's. And once they kill the y's, you can go on. Now, once you get your x values, you can use any equation you want, any, to calculate your y's. All right, cool. Got it. So that's your nonlinear stuff, guys. It's not, huge issue. But then, right, how many questions on exam 3? 10, I guess. I'll be writing that thing tonight. I have 3 exams that I just had. I mean, students just had 3 exams. So now I have to deal with you and Calc 2. And then on Sunday, I have 5 final exams. Woohoo! Yeah, 10 questions, 91 minutes, yes, by popular request. Well, the review and everything else, I mean, I did that, right? Right? It's in the email, it's in the announcement, it's in the video for the review. Yes. You guys requested extra time. I can always give extra time. It's okay. It's not a problem, right? Standard time is 1 hour, 20 minutes. That's the standard time, so 80 minutes. I add extra because, you know, you guys are awesome and I'm awesome. We're all awesome. We're all breathtaking. All right, I'm going to restart the stream for our optional 7.3. And then 7.3 is important for those students that will eventually go to Calculus 2 and differential equations. So you can enjoy what we call partial fraction decomposition. And see, Paul knows it. The best person I'll ever meet in the whole galaxy. Exactly. In the galaxy. See, there you go. Now, no one will do 7.3 in Precalc 2. That is the topic, optional topic for Precalc 1. Optional topic for Precalc 1. Now, it's mandatory topic in Calc 2 and differential equations, but you do calculus on top of it. So this is an algebraic thing that you will have to use a lot in those other courses. So right now we are only going to take a look at, you know, the meaning of this and what it does. You know, to see one problem, just to be, you know, informed, so that once you have to use it in Calc 2 and differential equations, right, those of you who go to those courses, obviously, you are not, you know, completely blown away. Now, I'm going to, actually, no, you know what, I'm just going, since it's optional, I'm not going to stop the stream, I'm just going to continue talking, and I'm going to pull the partial fractions 8.5. Why is this empty? Calc 2, partial fractions. Okay, I don't know why is it empty over there. Maybe it was a network glitch or something. Anyway, partial fraction decomposition, that's your 7.3 optional. And let's go and take a look what it is. In basic algebra, you get the problem with two rational functions like this that you are supposed to add together. So I just want to add these two rational functions. You know how to do that because you took algebra. You find the common denominator, in this case x minus 4 times x plus 1, and then you cross multiply, right, to get the common denominator together. So x plus 1 is missing on the first, x minus 4 is missing on the second, or just cross multiply, whatever. You get your 3x plus 3 when you multiply these guys. You get your 2x minus 8 when you multiply the other ones. Combine like terms to get 5x minus 5 over this. And that is, you can see over here, I said it is algebra if you read it from left to right. So now, what is the partial fraction decomposition? The chocolate. Yeah, I can hear mine upstairs. I think they're drilling for oil right now. I don't know how much of it is getting into the recording. And I haven't heard dog in about an hour, so I just hope dog is alive. So yeah, I completely understand when you write that. Yeah, but I think if they find oil, then there will be no more lecture streams. Obviously, it's yeah. Anyway, so when you just use the common denominator, use the algebra over here, you will add into a single fraction at the end, and that's it. Now look at the red arrow underneath. When your problem starts here, the procedure that we teach is going to be partial fraction decomposition to get this into two or more fractions. So partial fraction decomposition. You see that these are separated from each other. They are fractions, and it's decomposed from here. They were together and now they're separate, right? So decomposed. So partial fraction decomposition. In the words, it's really the dog just barked up there. Dog is alive. There we go. All right, that was just a quick update. So we are learning these 4 setup cases, and this is stuff that you will be memorizing if you go to Calc 2 differential equations. And here is the problem. You get this, and you are supposed to decompose that into a couple of these. Well, you look at your denominator, you see that you have 2 distinct factors in denominator. So you give each one of those appropriate setup from the list above. Since both of these factors are what we call linear factors, and they fall into this category here. Why did I use blah? Because we don't care what's on top, right? We just know that these are linear factors. So the setup is a constant divided by the same linear factor from the left. So you can see that you can see that I copied x minus 4 and I put a on top, and then x plus 1, and now I'm using b because it's still a linear factor. So I am going to use the next available constant, which is b. Then I'm going to use algebra to cross multiply, so you get your ax plus a and bx minus 4b. And you can see this arrow now which says compare numerators. So now this equals that. Because denominators are the same, so just you need to have the same on top. And that's what this equation is. When you equal 5x minus 5 to this AB business. And you just need to solve, you just need to solve that, get your A and B, and once you calculate A and B, plug them where they go, and you are done. Now the question is, how do we solve this equation on the bottom? If you carefully look, you will find the red check marks and the blue check marks. All of the red check marks have x's in them, and all of the blue check marks have no x's in them. So that's where you are going to create two equations. You see the red equation is for x's. A plus b equals 5. You just ignore those x's. A plus b equals 5. Those are the red ones. And then a minus 4b is negative 5. That's the blue ones, blue check marks. That's generally the trickiest part of the whole thing. Right? Once you have the system now, it just flies. So technically, what you are seeing now on the screen is the procedure for partial fraction decomposition. The rest is just solving the system. You get your A and B, you're done, right, in 2 lines. But the core of figuring everything out is exactly here. So what do? I solve for A and B. I get that A is 3, B is 2, and when you go all the way up there, see, 3 over x minus and 2 over. So we were able to decompose it and get the value. So this is actual Calculus 2 lecture where I teach this method, because as I said, depending on how your semester goes, you might not have time to teach partial fraction decomposition. Your last lab is supposed to be on partial fraction decomposition. Now we know how this semester went, so yeah, there is that. But as you can see, there is calculus to be done. And you can see that I am doing partial fraction decomposition within integration. So I can't integrate, whatever that means in calculus, but if I break it apart using partial fraction decomposition, which is this part here that you were supposed to be learning today, right? Then you break it into something that you can solve using Calculus 2. Later on, all of that stuff pours into differential equations. Laplace transforms right here, where we have the same, let me just find it. There it is. Now, instead of using x, you are using s as a variable, but I have 2 linear factors. Each one gets their own constant. Here is the partial fraction, here is the system, here is the AB solution. There is no difference, right? It is that particular method of solving used across the coursework. So it's not something that you are doing now for the grade and that's it. If you are going to Calc 2, if you are going to differential equations, if you're engineers, all right, you are going to see this in many courses. So, you know, at least you have seen and have the idea that it exists, and, you know, it uses equations, right, of 2 variables or 3 variables or so on. They can be way more complicated than that. Here is another partial fraction decomposition here, which has the linear term, quadratic term at the end. We did have a quadratic term in our setup with those blah. I did not have an example with those terms. But here is the unbreakable quadratic, and there is the, we had cx plus d in that one because a and b were taken already. But, you know, these can be combined in any way. All of these can be combined. So you can have one of these and one of these, or you can have maybe 2 of these and 1 of these and 1 of these, right? They just go, and whatever the problem is, your job is to learn to memorize the 4 basic setups. Again, this is optional section for us here, so I'm just flying through this stuff, making you aware it exists. Later on in Calc 2, when you learn the details and so on, you will memorize these setups and so on. So the course is officially over, right? No more lectures. You guys have an exam on when? I gotta get my cheat sheet because I have 20 exams left. Precalculus1 May 7th, which is tomorrow, and tomorrow is Thursday. There we go. Okay. So Thursday, tomorrow is exam 3, and then when that ends on the 9th, the 10th is your final. And you're done. Now, I'm going to mention it one more time. If you missed any of the exams, 1, 2, or 3, you must take the final to fill in the missing grade. If you didn't miss any of the exam, and you like your average of tests, you can skip final exam. The average of tests will be plugged in. Yes, Paul. Yep. 10, 11, and 12 for the final, which you can skip or you can take depending on how well you did on the other 3 exams. So, exam 3 on chapter 3 is tomorrow. You take that exam tomorrow or on Friday or Saturday morning. It closes Saturday at noon. That's exam 3. We had the review last class. Exam 3 will be over on Saturday, and then the final starts on Sunday for 3 days. Sunday, Monday, and Tuesday by midnight for final. If you like your exam average, 1, 2, 3, you do not need to take the final. You can. You don't have to take the final. The average of your 3 exams will be plugged in for the final. If you decide to take the final, whatever grade you score for the final will be used. So do not log on and see, oh, I don't feel like doing the final, but you started it and then you just abandon it. Well, if you score 17 on the final, 17 is calculated as 30% of your grade. So you can either log into the final and do everything and submit, or do not log into the final at all, and then the average of the exams will be used. But there is no taking it back. You take the final and then you say, no, I don't want to, right? So if you take the final, it counts. If you do not take the final, then the average of the exams is used. So finally, in that respect, is optional. You guys go and take exam 3 and then see what's happening with your average. We can do office hours / review on Monday if you want to. You will have Monday all day and Monday and Tuesday all day till midnight. So if you have questions and things, sure, we can have a review on Monday. Technically, we don't have office hours and reviews during the week of the final exams, but this is a very, very special semester, so yeah, why not? Fine. So Monday, 6 p.m. Review for this course. You bring your questions from chapters 1, 2, 3, and 7 if you are taking the final. If you're not taking the final, you take exam 3 and you're done with the course. Any other questions, concerns? While you still have me, I have to go after this and make exams. YouTube, 6 p.m. on Monday. Yes, for the final review. Exam 3 review was done on Tuesday. You can go look for the video on the channel. YouTube, 6 p.m. on Monday is going to be for final exam review for those of you that want to take the final. Oh, you're very welcome. Yeah, I'm nice like that. Yes, I don't know what's happening with Summer 2 now that they switched to online. In Summer 1, I am teaching Calculus 2 and 2 sections of differential equations. For Summer 2, I was supposed to teach Calc 2 and Calc 3. I'll definitely be teaching. I know that I am not teaching, for a fact, Precalc 2 at all over the summer. So it might be, I don't know what's happening for the fall yet, whether or not I will be, because I'm hired to teach calculus, differential equations and stuff like that, right? Precalc1 and algebra classes, and so those are the fillers. My workload is calculus, right? How many chapters in Precalc2? You have chapters 4, 5, a little half of 6, and chapter 9 has 3 sections, I believe. So it's pretty much the same as Precalc1, and it's pretty much all trig, which is insanely important for physics, engineering, and calculus. Obviously, half of your problems are gonna be trig in calculus, so very important. And I don't think I have any of the Precalc2 stuff on my channel on YouTube either, because I haven't taught Precalc1 in 5 years, maybe, maybe more. As I said, I rarely teach. Precalc1 last time 3 years ago, maybe. I don't know, stats like 2 years ago, and so on. It's very rare for me to teach pre-calculus courses, so yeah, we'll see for the fall. We don't know yet. They're talking about the hybrid semester and a whole bunch. I'll know more eventually when they make up their mind, but yeah, situation is terrible with online teaching. It doesn't work, I understand. We're making it work somewhat, but it's nowhere close to what in-person does, so hopefully there'll be some sense to go back and teach the proper way. But let's let's make the best out of the crap we're in, and then we'll deal with the rest later. So I will see you guys again, hopefully on Monday. Please don't forget about the exam. It opens tomorrow at noon, so you could go tomorrow at noon. I am going to post the announcement once the exam is available, which will generate email to all of you. And yeah, we'll go from there. Why Monday? You're not paying attention. Review for the final. Yes, tell her. Tell her. Okay, good. Oh, you guys are awesome. I love it. So, yep, that's it. That's it. And I am paying attention, lol. Okay, you just missed that crucial piece of information. The rest you paid attention. Okay, fine. So, those of you taking the final, you can, even if you're not taking the final, tune in on Monday at 6 for the final exam review. Again, if you missed exam 1 or exam 2, or you have a terrible grade in any of them, maybe you want to take the final to fix all of those issues. But if the average of the 3 exams is above 70, and you're happy with it, then you're done. Oh, I was told to stop, so I'm stopping. Bye.